Hi everyone, in this video we're going to look at one of the reactions of alkenes, which is the addition of a hydrogen halide via an electrophilic addition reaction. You can see that the alkene carbon-carbon double bond is a region of high electron density, and this pi bond within the alkene is going to act as a nucleophile, attacking an electron deficient species, which is this hydrogen, and then we have the addition of the halide in another step. So the net result is we have an addition of hydrogen to one of the carbon atoms in the carbon-carbon double bond, and the addition of the halogen to the other carbon atom in the carbon-carbon double bond. So we get this haloalkane or alkyl halide formed. The mechanism of the reaction is as follows. So what I'm firstly going to do is I'm going to look at an symmetrical alkene. So I'm going to look at ethene as my example. So the mechanism, adding, I'm going to call it to HBr. So a pair of electrons from the pi bond, remember the base of the arrow comes from the centre of the bond, and attacks this delta positive hydrogen. The hydrogen bromine bond then breaks to produce a bromide ion. So this will then produce something called a carbocation intermediate. Now the key is here that both of these carbons are basically equivalent. Both these carbons in the carbon-carbon double bond have got the same thing attached, i.e. two hydrogens. So it doesn't necessarily matter which of these two hydrogens these two carbons that this hydrogen adds to. So we get this carbocation intermediate. So remember valence rules, we've got 3 bonds to a carbon. In this instance it needs a positive charge. Bromide ion then will then attack this positively charged carbon, and that then gives us our product, which in this case is bromoethane. Okay, so that's your mechanism for the reaction of a alkene and a hydrogen halide. But the question is, what happens if I have an unsymmetrical alkene? So an example there would be propene. So propene is unsymmetrical. And in this case, my two carbons are not the same, because this carbon's got a CH3 and a hydrogen. This carbon's got 2 hydrogens. So it does make a difference. And we could potentially get 2 products. So what we could get is the bromine adding to carbon 2 to give us 2 bromopropane, or just move this down, the bromine adding to carbon 1 to give us 1 bromopropane. Now this here is what we call the major product. This is actually the alkyl halide which is formed in the greatest quantity, and we call this the minor product. This is also called, when we get addition to give this major product via this mechanism, this is sometimes called the Markovnikov product, or Markovnikov addition. I should call that Markovnikov addition. And to understand that, we need to look at the mechanism for the reaction of propene with HBr. So let's just get propene, and if that reacts with HBr just in the similar way that we looked at with ethene, again, base of the arrow from the centre of the carbon-carbon double bond from the pi bond, and we break the HBr bond. One of the possible options, one possible option is to produce a carbocation. Where the positive charge is on the second carbon, carbon 2. So we'll kind of number these 1, 2, 3. This here is we call this a secondary carbocation intermediate. And we've got 2 electron donating alkyl groups. So these alkyl groups that I'm going to circle now are, we'll call these electron donating. So you've got these 2 electron donating alkyl groups, and they will stabilise then this positive charge on the carbocation. And it does this via a process called hyperconjugation. But these are electron donating groups, and they donate negative charge to this carbocation. Obviously, what would happen then is your bromide ion would then react and that would give us a product of 2-bromopropane. That would give us our major product. So this is the major product because it is formed via the most stable carbocation intermediate. Let's just prove that. So if I was to then show you what would happen if the hydrogen adds to carbon, the other carbon, in this case carbon 1, so the hydrogen actually is going to add to carbon 2 in this case, and we've got the positive charge here on this carbon. So this now is an example of a primary carbocation intermediate, and here we've only got 1 alkyl group, 1 electron donating alkyl group, and this therefore is less stable, and therefore this would react with the bromide ion to give the minor product. This would then give us 1 bromopropane. So when we're looking at an unsymmetrical alkene, we've got 2 potential products formed. The major product, which we call Markovnikov addition, and the minor product. This is the major product because this is formed via a more stable carbocation intermediate. This is the minor product because it's formed via a less stable carbocation intermediate. And that there is electrophilic addition, the addition of HX to an alkene.